Video, we are going to be discussing the basics of fractions. To start off, let's talk about the parts of a fraction. The number in the top of a fraction is called the numerator. The number in the bottom of a fraction is called a denominator. The bar in between we call a fraction bar. It can also symbolize division. Visualizing a fraction, what we're going to look at is a whole piece broken into the number of parts in the denominator. And in the numerator, we're talking about the number of pieces we're being discussed, and we're going to color those in if we're going to represent them in a picture. Now, as far as dividing a whole thing into parts, what you want to look at is how many ever parts you're dividing into, your denominator, and you're going to use one less line to divide that up. So we have a whole thing here and we want to divide it into 3 parts. So I'm going to use 2 lines to do that. And when we break a whole thing into parts, we want to do that as evenly as humanly possible. So these pieces are considered to be even breaks. So there are 2 types of fractions. The first one we're going to talk about is the one that we have visualized already. It is a proper fraction. A proper fraction is a portion of one whole. In a proper fraction, the numerator is smaller than the denominator. Now we can represent this on a number line too. That's another way to visualize it. And a proper fraction is going to be placed somewhere between 0 and 1 because it is less than one whole. So to put it on a number line, we will break this number line into even pieces that are three even pieces. So I'm going to use 2 lines to do that, and I'm not going to do any counting or anything. I'm just going to kind of break these in there equally. So this piece here is 1, this piece here is 2, and this piece here is 3. 3/3, the fraction of 3 over 3, is going to represent one whole. In fact, any number over itself always represents one whole. So this is representing 1/3, and this one represents our 2/3. And to graph anything on a number line, you should know that you put a dot on the thing that you want to represent that says here it is, and then you always highlight that thing. So this is 2/3 right there. And that's another visualization of a fraction. Okay. Now let's talk about the other type of fractions, improper fractions. Improper fractions represent a whole or more. So that fraction of 3 over 3 that I wrote on the last page, that would be an improper fraction. In an improper fraction, the numerator is greater than or equal to the denominator. A visual of an improper fraction starts with 2 or one whole thing or more. So 5/4, since the numerator is larger than the denominator, we know is going to represent more than one whole thing. So I'm going to have 2 whole pictures divided into 4 pieces each. This denominator represents how many pieces each whole thing is broken into. So you see my first rectangle and my second rectangle each have 4 pieces. 1, 2, 3, 4. 1, 2, 3, 4. That's a very, very important thing to realize. The numerator tells us how many pieces I am going to shade. So I am shading 1, 2, 3, 4, and there's a 5th one. So 5 pieces are shaded. And each whole is broken into 4 pieces. That's where the denominator comes from. Now in doing this on a number line, what I have to realize is that this is more than one whole. So this is going to be represented between 1 and 2. So we want to make sure that we get this out to 1 and 2. And then I'm going to break this number line into 4 equal pieces, and remember that breaking it into 4 equal pieces requires me to have broken it down by using 3 lines. And you see between 1 and 2 I use 3 lines to break it into 1, 2, 3, 4 equal pieces, right? Now, I already see from this improper fraction that I have more than one thing, so it's not really necessary to break from 0 to 1 up into 4 equal pieces as well, but you certainly could do that. It's just really not actually necessary. But in terms of saying, okay, well, we're going to count off the 5 equal pieces, let's just take a look at that. So now I've broken down between 0 and 1 and between 1 and 2 into 4 equal pieces each, right? This between 0 and 1 represents this first whole thing, and between 1 and 2 represents this second whole thing. So now I can count them off. There's 1 quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters being right there. So let me mark those off. 1 quarter, and then 2 quarters, and then 3 quarters. And we already see that 1 is equal to 4 quarters, right? 4 fourths, or 4 quarters. And then this one is our 5 fourths, or 5 quarters there. We use the word quarter because we are very familiar with breaking anything into 4 pieces, like a dollar into quarters. So that's one of the terms when the denominator is 4. And then, of course, just like before, we would symbolize this on a number line by putting a dot right there on the 5 fourths and then highlighting the fact that this is 5 quarters. All right, now moving along, we're going to talk about something called equivalent fractions. These represent fractions that are the same portion, even though the numerator and denominator are different. So 1/2 is equivalent to 2 quarters. We can look at this visually and see that. So I have 2 whole things here that have been broken into a different amount of pieces. So the top one has been broken into 2 whole pieces, right? 1, 2. And the bottom one has been broken into 4 whole pieces. 4 pieces. 1, 2, 3, and 4. And what you see here is that when I shade one of these and I shade 2 of these, I'm looking at the exact same picture. Now a little later on we will learn how to move mathematically between these 2 equivalent fractions, but I'm not focused on that right now. I just want to get across the idea of what an equivalent fraction is and how we could visualize that. I could also visualize it on a number line. If I want to take this and I want to do a quick little number line here and I say, okay, well here's 0 and here's 1, and I'm going to break this into half right here, right? There's half. And then another thing I could do, I could break each of these into halves. And now what you see is that I have quarters. There's 1 quarter, 2 quarters, 3 quarters, 4 quarters. So this here represents 1 quarter, and this here now represents 2 quarters as well, and this one represents 3 quarters. And you see that just like I saw in the visual representation here, that this point at 1/2 represents both 1/2 and the 2 quarters. And so we see very visually that 1/2 and 2 quarters are the exact same fraction representation. They're equivalent fractions. All right, now let's talk about mixed numbers. Mixed numbers tell us how many whole things plus how many parts of another whole. If they were broken into the same amount of pieces is our assumption. So in our first one here, we see a whole thing and I have broken it into 4 parts, and I see a second whole thing and I see it broken into 4 parts as well. So I have one whole thing here, this addition symbol, that's the word and, right? I have this one whole thing and I have this one of 4 things. And so this is equivalent to 1 and 1 quarter. Now it's important that you understand that this is what we call the expanded notation of a fraction because of, or excuse me, not of a fraction, of a mixed number. Because a mixed number really does represent 1 1/4 represents 1 plus 1/4. So this is our expanded notation of a mixed number. And that can come up later on when we learn to add and subtract mixed numbers. So do you recall that an improper fraction could be used to represent this same picture here, where we had in the numerator the 5 representing the number of things that were shaded, and then in the denominator we tell how many pieces each thing is broken into, and each thing is broken into 1, 2, 3, 4 pieces, 1, 2, 3, 4 pieces, and so the denominator is 5/4. So that improper fraction is the same as this mixed number. And we are going to talk about moving between mixed numbers and improper fractions. You can move from a mixed number to an improper fraction. That's this part of the double-headed arrow. And you can move back to a mixed number from an improper fraction. So we're going to start first of all as an improper fraction, and then we're going to change it to a mixed number. In order to do that, we have to have our division well in hand. So we have to be able to divide the numerator by the denominator. The quotient, remember quotient means the answer to a division problem, the quotient is a whole number. Then the remainder, what's left over, because it won't go in evenly, right? So what's left over is the fraction's numerator. And then the fraction's denominator is the same as it was before. So let's take a look at that with 5/4. So I'm going to take the numerator and I'm going to divide it by the denominator of 4. 4 will go into 5 one time with a remainder of 1, since how 1 times 4 is 4 and 5 minus 4 is 1. And so that's my remainder. So this is my quotient right here. So that quotient becomes my, let's do this one. This quotient here becomes my whole number, and then my remainder here becomes my new numerator, and my denominator is the same as it was before. And that's how we make a mixed number. Maybe you should try that on your own with, let's do 7/3. So you try that one on your own. Okay, so 7 divided by 3. 3 will go into 7 2 times. That's 6, subtract, and that's 1, so remainder of 1. And so now we see that this 2, that's our whole number. This 1, that's our numerator. And our original denominator is a 3. And so that's our answer there. Now a mixed number to an improper fraction. We're going to multiply the whole number and the denominator. We're going to add the fraction's numerator to the product from 1. And then we're going to put the sum in step 2 into the numerator of a new fraction with the denominator that's the same as the old. Let's try it here. So we'll do 1 times 4. And then after we do that, so I'll put parentheses around that, I'll add the numerator of 1. And then it goes over the original denominator 4. So what I get is 1 times 4, which is 4, 4 plus 1, which is 5, and the old denominator of 4. And there you go. You might want to try taking our mixed number that we just came up with before, 2 1/3, back to its 7/3. All right, that ends it.